Bowers Ridge. Have you ever looked at Alaska on a mapping program and noticed this massive underwater mountain range in the Aleutians that seemingly begins north of the Semisopochnoi Island? I have received many queries regarding this feature, which while few maps have it labeled is known as the Bowers Ridge. And this submarine ridge is actually connected, or more so, was originally connected to another underwater mountain range off of Kamchatka known as the Shirshov Ridge. These features just so happen to have moved apart to the east and west 220 miles since their initial formation. But why and how did these two large features form, and what secrets might they hold? Today's video will answer these questions. Modern volcanic arc. Today, the Aleutian Island arc stretches for nearly 3,000 kilometers between mainland Alaska and just offshore of Russia's Kamchatka Peninsula, marking the region where volcanism has occurred due to the collision between the North American and the Pacific Plate. Partial melting from this collision migrates upwards slightly rearward of the actual collision site, hence the various active volcanoes such as Cleveland, Shishadin, and the currently erupting Great Sitkin Complex. However, the apparent interconnectivity of this chain might make it seem like it all formed at the same time. In reality, this is not the case, as it consists of two separate segments that would later merge. The cutoff point for this is the ground between the western edge of the Fisher caldera and the eastern edge of the West Dal volcano. In other words, the segment to the east had old bedrock, while the segment to the west was far younger. Before the western segment formed, a different plate boundary existed, which between 70 and 56 million years ago created a chain of volcanoes between what is now Unimak Island and Cape Navarin. However, this plate boundary later back arc basin jumped west in association with the formation of a back arc basin. As this spreading continued, it would lead to the formation of the Aleutian Basin, marking the modern low point. Around 33 million years ago is when both the Bowers Ridge and the Shirshov Ridge were active island arcs, although it is still unclear when exactly they separated. What is known is that a major transform fault pushed them apart to the east and west by hundreds of miles at some point. This separation formed the apparent gap between the Shirshov Ridge and the Bowers Ridge. However, while this transform faulting occurred, volcanism continued to form various island volcanoes, but some lesser volcanism also occurred on the transform fault since it represented a path of least resistance for magma to intrude into. This is why there are only a few but still are some seamounts visible in the gap between the two volcanic ridges. Regardless, for millions of years a large volcanic island arc existed, which given the 9°C warmer temperatures compared to the modern era probably was too hot to form glaciers at the tallest peaks. Volcanism continued for 11 million years before ceasing 22 million years ago. By then, the plate boundary has essentially shifted to its modern location. The youngest dated feature appears to be the Bowers Seamount, which last erupted 22 million years ago via a submarine eruption, with this volcano never reaching the surface. As a final note, I would like to thank my new YouTube channel member Chaz de Geoffroy for